We now know how to solve quadratic equations by factoring. We know several different strategies to factor, including the ones we learned last unit. So factoring simple trinomials, multi-step factoring, which is common factoring first, and then using simple trinomial factoring, as well as a special case of the difference of squares. And as of last week, we also now know how to factor complex trinomials using either crisscross factoring or decomposition, whichever one you prefer. Today we're going to look at how we can solve quadratic equations when they are not factorable. Okay, so despite the numerous methods of factoring that we know, there will be quadratic equations that are not able to be factored, but this does not mean that they don't have any x-intercepts. It just means that their x-intercepts are not nice whole numbers or fractional numbers, in the sense of ones that we can work out easily. Okay, so we're going to talk about the quadratic formula today and how we can use it to solve unfactorable equations. Okay, so this is the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Okay, so this obviously looks a little bit intimidating. There's a lot going on in the formula, but I'm going to show you how to use it, and it's not really that difficult once you know how to do the order of operations correctly. You won't need to memorize this. You'll be given it on the test, and obviously the course is online, so I can't stop you from using your notes to look at this. However, I will link a video with a song from another creator on here who has video with it, and it's to the tune of Pop Goes the Weasel, and it was how I was taught the quadratic formula, and it's how I still remember it to this day. I sing the little song in my head while I write it out. So I will attach that video with a link in our classroom, and I will also add it to my quadratics playlist. So this formula here has three variables, a, b, and c, and these variables come from the standard form of a quadratic equation, which is y equals ax squared plus bx plus c. Okay, so we are familiar with standard form. That's where the a, b, and c in this formula comes from. And like I said, we use this when we can't factor. We can also use it on an equation that is factorable. However, factoring is a lot faster, and there's less room for making mistakes with it. So when you can factor, you should factor because it's just, like I said, more straightforward and you're less likely to make mistakes. But there are cases where you can't factor, so you have to use quadratic formula. Okay, so I just kind of want to go over what's happening in terms of order of operations here. I'll talk about a few more things and then I will show some examples. Okay, so this here, the negative b, essentially what that means is we flip the sign on the b. Okay, so like let's say in your equation here, b is positive 2, you would write it in as a negative 2 here. This symbol here, you likely have not seen this before, and that's okay. We say this is, like the way we say this is plus or minus, and what this means is once we've solved under the root here, and taken the square root of it, we can have a positive version or a negative version. And I know that seems like, what? How is that even possible? However, I'm going to show you off to the side here why this makes sense. So if I were to ask you to find the square root of 4, let's say, all of you would say 2, okay? And you likely don't even need a calculator to do that because it's just, 2 times 2 gives you 4. However, your calculator only ever tells you the positive root, and for most of your schooling career, all of the math you've done, you worked with positive numbers and not really negative numbers, especially when it came to doing square roots. So something important to note is that we can also create 4 through repeated multiplication by doing negative 2 times negative 2, and that gives us positive 4 as well. Okay, so really when we do the square root of 4, our answer can either be 2 or it could be -2. Your calculator will never tell you -2 unless you have it programmed a very specific way if you're able to, because it just always gives you the positive root. But we know that it can also be a -2. Like I said, because -2 times -2 gives you a +4. So there's actually two options for a root. So really, anytime you're taking the square root, especially in a case like this, you can have plus or minus the square root because there are those two options. Okay, so we'll look at it with some numbers in a little bit, but it'll make more sense with that. Okay, so that's the quadratic formula there. We use it with standard form equations, and we use it when we can't factor. And similar to last week when we looked at solving equations by factoring, if we have equations where there are x squared and x terms on both sides, or really just terms in general on both sides, we bring everything to one side, simplify, and then use the quadratic formula. Okay, so again, I'll show an example of that in a few minutes. But this would be something if it was like I'll show an example of me solving it, but if we had like maybe 3x squared minus 14x plus 10 is equal to, let's do -2x squared plus 9x minus 7. So similar to the ones that we did last week, you would bring everything to one side. It doesn't matter which side. You likely would try to factor first just to see if you are able to, because like I said, it's easier to factor if you are able to, and then if not, then you would use the quadratic formula. Okay. Now, occasionally there will be times where there are not any solutions, which means that there are no x-intercepts. Okay, so we've seen before that if you have a parabola that it sits with its vertex above the x-axis and opens up, or if it has its vertex below the x-axis and it opens down, that there won't be any x-intercepts. So if this is the case, what will happen is the number under your square root will be a negative. Okay, because we cannot square root a negative. And the reason for this is because a square root means that you achieve that number by multiplying the same number by itself twice, and you cannot multiply the exact same number by itself twice and get a negative, because to multiply and get a negative you need to have a negative and a positive, which is not repeat multiplying the same number. Okay, so for example, if I had, well actually here I'll show this example in a moment once I do some regular examples. Okay, so this first one here that we will look at, this is just a regular old um, quadratic formula here. We want to find the x-intercepts of this equation. So the first thing we would want to try to do is to look and see if we can factor. Okay, so this is a complex trinomial. We know that because the number here for our a value is not 1. So we first would check, can I nicely divide all three terms by -2? The first term, obviously, yes, you can. 4 divides nicely by -2. 3, although it gives you a good decimal number, it's not a whole number, so we cannot divide all three terms by -2, which tells us we can't factor any further than this. We can't factor at all, so we are going to use the quadratic formula. So first we want to determine what our a, b, and c values are. So a is given by this value here, -2. B is given by this number here, which is 4. And C is given by the last number, 3. Okay, so I like to write down my ABC values so that I know what they are and I don't make any mistakes. And because this is our first time using the formula, I'm going to write the blank version of it here. So x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. And now I'm just filling in what I know. So I'll have x is equal to -b. So b is 4, so I'm going to write this as -4 plus or minus the square root of 4 squared minus 4. This is all multiplication here, that 4ac. So 4 times negative 2 times 3. And then the whole thing is divided by 2a. Make sure you pay attention to the signs here. So 2, and then a is negative 2. Okay, so that's how we fill everything in, and then we need to evaluate using BEDMAS. So the first thing I'm going to do is under the square root here, I'm going to show calculating this in a couple steps. So this is sort of similar to the trigonometry unit that we did right when we started this class, and using cosine law, where we had like that subtract and then sometimes it was a negative. So the way you calculate this kind of depends on what makes most sense to you and what you are comfortable with typing into your calculator. So typically I just type this whole thing into my calculator, but I put a bracket around, like I would do 4 squared minus bracket 4 times negative 2 times 3 bracket, and then my calculator will use BEDMAS appropriately. For some of you, depending what calculator you are using, you won't be able to do that. So just make sure you pay close attention to the signs here. So what I'm going to do is the first step, I'll have x equals negative 4 plus or minus the square root. I'm going to calculate that 4 squared first, which is 16, minus, and then when I type this on my calculator for the sake of this, like I said, I'm going to show it in a few steps. I'm typing just 4 times negative 2 times 3. Okay, I'm not typing negative 4 just because I want to show you what's happening here. So 4 times negative 2 is negative 8 times 3 is negative 24. So you end up here with subtract negative 24. This is a square root. And then on the bottom, we're doing 2 times negative 2, which is negative 4. Okay, so like I said, this is why it's similar to when we used cosine law, because we end up with subtracting a negative here, which is often what happens. And we know that when you are subtracting a negative, you're actually just adding. Okay, so this is going to be 16 plus 24 underneath the square root. Again, pay attention to your signs with this so that you don't make a mistake. So 16 plus 24 is 40. If you type it in all in one go correctly in your calculator, you should get 40 anyways. And then on the bottom, we have negative 4. Now, this is the spot where I see students making a mistake very often. We are not going to do negative 4 on the top, negative 4 on the bottom, cancel it out. That's not how BEDMAS works. We have to solve the top first, or evaluate it first, and then divide the whole thing by negative 4. Okay, so we need to figure out whatever the square root of 40 is, figure out the top, and then divide. Okay, so do not cross this off because they are the same and say, okay, it's just plus or minus root 40. That's not how the order of operations works, and that will give you an incorrect answer. Okay, so what this looks like, then I'm going to show this over here because I have run out of space here. The first root is going to be x equals negative 4 plus root 40 divided by 4. And then the second option, because we typically have two x-intercepts, the second option is going to be negative 4 minus square root of 40 divided by, and sorry, it should be divided by negative 4. Okay, so that's where we get the two x-intercepts from, because one of them we use plus, one of them we use minus. Okay, so once you've fully simplified everything as far as you can with the BEDMAS, then you do plus and minus. Some people prefer to evaluate root 40 and write an approximation of it here and then continue on. I usually on my calculator will just type this in as negative 4 plus square root of 40 equals divide by negative 4. Again, whatever makes most sense to you to get the correct answer every time. So this here, negative 4 plus square root of 40 divided by negative 4 should give you negative 0.58. I always just round to 2 decimal places for these. Okay, usually you're going to have a very long gross decimal. That's fine. That's what's expected. It's why we're not able to factor. But just round to 2 decimal places. Okay, and then with the second one, when you calculate that, you should get x equals 2.58. Something I will say also on your calculator when you're typing this in, make sure you do negative 4 plus square root of 40 equals and then divide by -4, because another common mistake I see is all just within the calculation. Some calculators, if you type it in without clicking equals after the root 40, it will do like -4 plus root 40 over 4, which we don't want. So just make sure you know how your calculator is working and you typed that in correctly. Okay, so then our answers here, we have two of them because there's two x-intercepts, -0.58 and 2.58, or you could write them as a solution set as we saw last week, which is with the curly brackets like this. Either way of writing it is fine. Typically, I'll just show it as x equals, I don't know, kind of just depends on how I'm feeling, to be honest, but usually I'll just write it x equals and x equals um, like this. Okay, so that's how we solve using the quadratic formula. Now, another example here is one where I have terms on both sides of my equal sign. So if this is the case, you want to move everything to one side, and then you can use the formula. So in this case, I'm going to bring everything to the left side. So I'm going to look at the right side and do the opposite of what's happening with each thing. So I've got 8x squared. So to bring that over, I need to subtract 8x squared. And I also subtract that on this side. Okay, so I write that directly below the only term that it impacts. I have -4x, so I'm going to add 4x to both sides. And then I've got -12, so I'm going to add 12 here, add 12 here. If you'd rather do this in in a few separate steps, that's fine as well. Again, as I always say, whatever gives you the correct answer every time. Okay, so now I'm going to calculate here. So I've got -3x squared minus 8x squared gives me -11x squared. 7 plus 4 is also 11x. And then I've got -35 plus 12 gives me -23. And this is now just equal to 0. Okay, so this actually was almost factorable here, but I've got, that's 23, so it's fine. So first I'm going to look and see, can I factor it? The first two you can divide by -11, this one you cannot. So we're going to use the quadratic formula, so I'll have A equals -11, B equals 11, C equals -23. Okay, and then I'm going to fill everything in. So I'll have x equals -b, so -11, plus or minus the square root of b squared, which is 11 squared, minus 4 times a times c, and then all of that is divided by 2 times a. Okay, so now I am evaluating using BEDMAS, so this is still going to be -11 plus or minus 11 squared is 121 minus 4 times -11 times -23 gives me positive 1,112. Okay, so there I don't need to write it in a bracket like this. I'm subtracting like that. Okay, and then on the bottom I am multiplying 2 by -11, which gives me -22. So then I'll have x equals -11 plus or minus the square root. Now here, when I do 121 subtract 1,012, I get -891 under my square root. And then on the bottom here, this is still -22. So if you were to try on your calculator to do the square root of -891, your calculator would say error. I'm using my phone as my calculator right now, and if you have a Google phone by any chance, you should try doing a negative square root and see what it says, because it's kind of funny. Anyways, it will give you an error on a regular calculator. It won't give you a little pun from Google, but if you use a Google calculator or Google phone, it gives you a little funny pun error. But you can't square root a negative number, so what this means is there are no x-intercepts. Okay, or you could say no solutions. It kind of just depends on what you're solving. So sometimes we're just solving a quadratic equation. So in this case, like this starting question was not a parabola because we don't have a y equals anywhere and there's numbers on both sides. So here you would say there's no solutions. If it was a parabolic y equals, then you would say there's no x-intercepts, okay? I wouldn't mark you incorrect for using the wrong wording, but just there is a correct versus incorrect depending on what the scenario is. Okay, so that is how we use the quadratic formula. Make sure you practice with it so that you're comfortable with the best way for you to type in everything under the square root. And like I said, you can use it with questions that are factorable, but you should try to factor first just because if you have factoring mastered, it is a lot faster and there's less room for error than there is with using the quadratic formula.